Good afternoon, everyone. This is lecture number 10, and we are dealing with connected bodies in Newton laws of motion. We have seen various examples of questions that can come, and we had also seen how we can solve those questions. Yes or no? Do we remember this? Everyone? We had seen the different examples, what all questions can come, and I think we are only left with one particular case. And I'll show you that one particular case, and I'll give you time to tell me what could be the answer in this case. Now, if I have this one, this particular case, let us imagine that I have this case. I have one block hanging like this, and the other block kept on the inclined plane. And let us say that it is given that this system is moving downwards like this. Do you see this acceleration of the system here? Do you see this acceleration? It is given as downwards here. So this block is definitely moving downwards. That means this block will definitely move upwards with the same acceleration. Yes or no? Yes or no? The question still remains the same. Can you tell me what is the acceleration of the system? Again, we have done so many problems on a concept, and I hope you can apply that concept. I'll give you 2 minutes. If you can apply it on your own, nothing like it. If you can't, well, I'm always there to do it for you. Try it. Shall I help you? Well, the only way we can do any problem is by drawing the free body diagram. This is M2G. This is already T. It is drawn. This is T, already drawn. Now, this block is kept on an incline. So this is M1G. Everyone understands this? Yes or no? Then there is a normal reaction coming from here. This is N1. And I told you whenever the block is kept on an incline, we'll have to resolve the weight. And you will have one component of weight. This will be M1G sine theta. Do you remember this? And this one would be M1G cos theta. Do you remember this? Everyone remembers this, yes or no? Now, you can look at the block. You can look at this normal reaction. This normal reaction would be equal to M1G cos theta. We have done question like this before, yes or no? Now, what we have to see here is the acceleration of this system. Now, as already told that this system is moving downwards. Now, look at the force. On the right hand side, we have a force M2G, which is trying to pull it downward. On the left hand side, I have this force m1g sine theta, which is trying to pull it this side. Whatever force is more, that will win. In this case, since it is given that it is moving downwards on the right hand side, that means m2g is more. Now you can apply your common sense and tell me what would be the value of acceleration. The value of acceleration would be, on one side I have m2g, on one side I have m1g sine theta. So the answer would be m2 minus m1 sine theta multiplied by g divided by m1 plus m2. Do we understand this? Yes or no? Then in rare cases, they might ask you to find out the value of t. How will you do this? You can write this pink equation for this block. What is the pink equation of this block? It is moving downwards. So m2g minus t would be equal to m2a. You can put the value of a from the above equation and get the answer. I don't want you to remember the value of t in all cases because you will get confused. The only simplified way is to remember the value of a, and how a is coming is same everywhere. You get the value of a and then you put it in the equation and you will get the value of t. I'll give you 1 minute to note this down. Anyone has any doubts on this? Okay, 1 minute. Do we get this, everyone? Can I now give you a question? Yes or no? Let's see if I have a ready-made question. If I have a ready-made question, then I'll give you that ready-made one. Else I will. Yes, I have a ready-made question. So I'll give this one. This is the question. Question number 1. The value of M1 is 10 kg. No, let me change the value. The value of M1, let us say, is 6 kg. The value of M2 is 5 kg. Can you tell me, okay, and this angle is 30 degrees. Can you tell me the acceleration of the blocks? You have 2 minutes to do this. Yes. Is there anyone with an answer? What is acceleration? So, where is this system going to move? See, this is 50 newtons. Yes or no? And how much is the force here? It is M2G. M2 is 10. Now, M2 is 60. 60 into G. Now, M2 is 6. 6 into G is 60. 60 into sine 30. How much is sine 30? Sine 30 is half. So you can see the force which is trying to pull it from here is 30. The force which is trying to pull it from the other side is 50. So what will be the acceleration of this block? 50 minus 30 divided by 6 plus 5. So the answer is 20 by 11. Do we understand this, how this is done? Yes or no? Anyone understands this? Can you solve one more problem on this? Okay, same diagram. I will change the values. Theta is again 30 degrees. Let us say this block is 10 kg and this block is still 5 kg. Can you now tell me the acceleration of the blocks? You have 2 minutes to do this.
అంటే ఇప్పుడు 10 ఉంది కదా 10 into 10 100 100 into 1/2 sin theta 1/2 కదా 100 into 1/2 50 0 0 by 15 0 15 0 0 అని చెప్పేసి 0 by 15
And the answer is 0, 0, 0, and 0. Yes, it is 0. Because if you look here, this is 50 newtons. This is 10 into 10, 100. 100 into half.
50.
It is also 50. This is 50. This is also 50. It cannot move. And the acceleration, my dear friends, is definitely 0. Do we understand this? Yes or no? No, yes. Huh? Ah. Comes the next question. Let's see who gives me the answer for this one. Let me make it. Let us take the angle as 30 degrees only, because this is the angle that is going to come. Let us take this as 5 kg and let us take this as 12 kg. I'll wait for your answer. I'll give you 2 minutes. Do that.
Minus 10 by 17.
What do you mean by minus? What do you mean by minus? You have to tell me the meaning of minus. If you don't tell me the meaning of minus, that is the problem.
Downward direction.
Which downward direction? Both the directions are downward. Which downward are you talking about? How will I know that, beta? Which downward? In which side is this going to move, bacha?
M1 downwards.
M1 will move downwards. That is correct. With what acceleration? With how much acceleration?
10 by 17.
10 by 17. That looks good. How are we supposed to do this? Again, we do the same stuff. This is 50 newtons. Mg is 120. 120 into half. So the pulling force here would be 60 newtons. 60 newtons is trying to pull it from here. Dung, 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 dung. 50 newtons is trying to pull it from there. Dung, 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 dung. So it is going to move this side. Yes or no? So the acceleration would be 60 minus 50 divided by 17. 10 by 17 meter per second square. Everyone understands this? Yes or no? No, yes. Got this? Okay. Think this is done. This is done. All these things are done. This is done. Okay. So let us move on to the next set of problems. And in the next set of problems, what is going to happen, bacha, is that up till now your what? Your string was massless. Now in the problems that are coming up, your string is going to have a mass. Your string is going to have a mass. Now, if your string is going to have a mass, how does the question look like? So the question looks like this. String with mass. Your string will have mass. Let us say small m is the mass of the string. String with mass. Small m is the mass of your string, and you have a block of capital M. Now, when the string has mass, bacho, the tension at this end and the tension at this end would be different. Yes or no? Yes or no? Now, at
Yes.
this end, if I apply the force F, at this end, if I apply the force end, I mean, I call this end as end A and I call this end as end B. If I apply the force at end A, the tension at end A would be equal to F. Do we understand this? The tension at end A is going to be F, but now the tension at end B will not be F. It will be something different, and then this system will move. So there are two things that they will ask here. The first thing is, what is the acceleration of the system? Second thing, what will be the tension at the end B? They'll ask two things. What will be the tension at the end A, and what will be the tension? Tension at end A is known. What will be the acceleration of the system? You have applied a force F on the system. What is the acceleration of the system, and what would be the tension at the end B? I know that you know how to do this, so I'll give you a chance to tell me. I'll give you 1 minute to think about it. What would be the acceleration of the system, and what would be the tension at the point B? I'll give you 2 minutes to think about it. Use what we have done. We have done this so many times. Tell me the answer. I'll give you 2 minutes. Yes, bacha. Anyone? Shall I do it? No one gets the answer. Shall I do it then? So much time. You're taking so much of time. That means obviously you are not thinking correctly. That means I must step in. So what is the answer here? The answer is very simple. And the, where is the pen? And the acceleration of this system is, I'll give you one last chance. F total force divided by m plus small m. Total force, net force divided by total mass is the acceleration of this system. Now, if you want to find out the tension at point B, what do you do, bacha? You just draw the free body diagram of body B. This is body B of mass m. There is a force tension here. It might be kept on ground. So there is M1G, Mg, capital Mg here. There is normal reaction here. We don't want to know that normal reaction. It is having a force T and it is moving in this direction with an acceleration A. It is moving in this direction. So to get the value of T, what I need to do is just write the equation for this block, and the equation for this block will be simply equal to T will be equal to M into A. You have already found out the value of A. Multiply this by the mass capital M and you get the tension in the string at point B. Do we understand this, what I have done? Was it so difficult? Was it so difficult? Yes or no? No, yes. Do we get this? Okay. Now, let me give you a question on this. As you can see here, there is a block of 5 kg and it is having a rope or string of mass 5 kg attached to it. And I am pulling it with a force of 30 newtons. You have to tell me two things. Number one is the acceleration of the system, and number two is the tension at this point A. What is the tension on the other side of the string? And what is the
Acceleration 2.
and what is the tension at the point A on the other side? Okay, I'll give you a minute. I know that you know the answers, but you have to give me two answers. So I'll give you one more second for everyone.
10. Tension 10.
Tension is 10. No, tension is not 10.
Tension is 20 Newton.
Tension is 20 newtons. That is correct. That is correct. Everyone got the answer in the class? I can't see hands of boys. Boys, did we get the answer? Everyone? Okay, that means everything is good. Now, how are we supposed to do this? So first of all, I can straight away tell that acceleration as total force is 30 divided by total mass is 15. It is 2 meter per second square. To find the acceleration, to find the tension at the end A, I will just draw the free body diagram of block 10 kg. Tension would be equal to MA. So tension would be equal to 2 into 10, that is 20 newtons. Do we understand this, yes or no? If I ask you a different question now, what is tension at the point B, which is the midpoint? What is the tension at point B, midpoint? Now apply some common sense and you would be able to get me the answer. I'll give you 2 minutes to tell me the tension at the midpoint. Tension at the midpoint is what I am looking for right now. Tension at the middle point. Tension at the middle point. Tension at the middle point. Anyone? Boys, girls, anyone?
15 meters.
Tension at the middle point of the rope. Bacha. Anyone answer? You don't have to do anything extravagant. You just have to do simple things and simple correctly. Yes, bacha.
5/6, sir.
5/6. Tell me, on the end A, how much is the tension, bacha? At the end A, how much is the tension? You found it out, na? What is the tension at the end A? What is the tension at the end A, beta? We found it out, na? Tension at the end A. Tension at the end A is 20 newtons, yes or no?
Yes, sir.
Tension at the end B is 30 newtons, yes or no? So the tension at midpoint, from here also you can understand this. One end it is 20, other end it is 30. So what is at the middle point?
10 Newton.
How much?
10.
At one end it is 20, at the other end it is 30. How it can be 10 at the middle? Cannot be. It is going to be 25 at the middle. And how do you get this? Remember, everything is moving with the same acceleration. You can take, my dear friends, this entire thing as one block. What is the total mass of this one thing? 10 is the mass of this one. Yes or no? What will be the mass of half of the string? 5 is the total mass. What will be the mass of half of the string? This half. How much will be the mass of this half? 2.5. So the total mass becomes how much? 12.5. Yes or no? The total mass of this one becomes 12.5. Yes or no? And this 12.5 is moving forward with an acceleration A. And who is making it to move? It would be the tension at this point B. Yes or no? Do we understand this? So this tension at the point B will be simply equal to 12.5, the total mass, multiplied by A. You can also calculate it from here, and you will end up with 25 newtons. Do we understand this? So this has gone above our head saying bye-bye.
Sir,
Yes.
explain once again, sir.
You can do it in many ways. Tension at one end is 20. Tension at the other end is 30. What will be the tension in the middle? This is not physics. This is maths. One end you have 20, the other end you have 30. What will be the tension at the middle point? Tell me. 25. Half. 20, 30, 25. What is this? If you don't understand it this way, then you can take this block and half of the string. This block is 10 kg. Half of the string is 2.5 kg. This is having the tension T. Now you can make the equation of this block. This T should be equal to total mass. Total mass is 12.5 multiplied by A. You will get the answer as 25. Do we understand this? Yes or no? Okay, I'll give you one more question. Don't worry. Everyone has understood this? I'll give you one more question. Don't worry about that. So now you have a block of 4 kg attached to a rope of 6 kg. The system is pulled by a force of 24 newtons. You have to find the acceleration of this system and tension at point A and tension at point B. I'll give you 2 minutes to do this. Take your time. Don't worry.
Acceleration 2.4 meter per second.
Okay. Correct. Acceleration is 2.4. Very correct. What about the next thing? Yes, bacha.
T
Shall I
is
do it?
equals to 9.6 newtons, sir.
9.6 newtons is the tension at point A. Yes. What about point B? You are going correctly. What is the tension at the middle point? Shall I do it?
28.
How it can be more than 24? It cannot be more than 24. 24 is the tension on the other side. Cannot be more than 24. Okay, so how are we supposed to do this? You take this entire block as one block and the mass. You will get the acceleration. You will get the acceleration as 24 divided by 10, 2.4 meter per second square. Yes or no? Then you take only this green block as your system. The net force on this green block will be tension at point A. Yes or no?
16.8.
Yes, it could be correct. It is correct. So if I take only this green block, the tension at point A should be equal to mass of this block 4 multiplied by 2.4. So this will be, I think, how much? 9.6 newtons. Everyone got this? Yes or no? Then what do? You go till this point and you take this entire thing as one system. So what is the total mass of this system? What is the total mass of this system? This will be pulled by tension at point B. So what will be the tension at point B? This entire thing is pulled by this. What will be the tension at point B? Tell me. 10. Oh, sorry. What is the total mass? 4 is the mass of the block and half of the string. Full string is 6 mass, 6 kg. Half of the string is 3. Yes or no? Total mass is 7 kg. Yes or no? 7 multiplied by 2.4. Multiply 7 by 2.4. Whatever you get, what do we get? 16.8. Is that so?
Yes.
16.8 newtons is the answer. Do we understand this, everyone? Boys? So we do one last question. And I hope that you are able to give me the answer for this one also. This is a block of 6 kg. This is a rope of 4 kg. It is pulled upwards with a force of 120 newtons. You have to find out the acceleration of the system and tension at this point A, the other end of the rope. You have a block of mass 6 kg, rope of mass 4 kg. You have to tell me the acceleration of the system, and you have 2 minutes to do this.
Acceleration 12.
Sir. Seriously.
Everyone got acceleration 12? Is that so? Is the acceleration 12? Everyone got this?
Tension is 72 Newton. 72 no. M into 12. అంటే 6 into 12 తీసుకున్నాం కదా ఏంటి 70 టెన్షన్ 72 అమ్మా
Yes. Do we have the answers? Everyone got acceleration as 12 newtons, 12 meter per second square?
Yes, sir.
There is a difference between this question
60 by 50
and this question. Do we see the difference between the two questions? This one and the other one? Or no? What is the difference? Do we see the difference between this question and this question? Do you see the difference? How are we going to do this? So we'll take this entire green thing as one system. Oops, 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 oops. This entire thing as one system. What is the total mass of this system? 10 kg. Yes or no?
Sir.
If I draw the free body diagram, this 10 kg is here. 100 Newton is downwards. Yes or no? It is going upwards with an acceleration A. What is the acceleration of this? How will you get the acceleration of this? 120 upwards minus 100, which is downwards, will be equal to 10A. Do we understand this?
Yes, sir.
In the previous question, gravity was not coming in between. Here, gravity is coming in between. So your acceleration, my dear friend, becomes 2 meters per second square. Everyone understands this?
Sir.
Block are not kept on ground, block are hanging. So gravity also comes here. Do we understand this?
Yes, sir.
Yes or no?
Yes.
So I'll give you one last chance to give me the value of tension at the point A. Tension at the point A. I'll give you chance to tell me the answer for tension at the point A. Yes?
12.
12. So to get the tension at point A, look at the diagram of this. This is 6 kg. So this would be 60 newtons. This would be tension T. And this block is going upwards. So what is the equation of this block? What is the equation of this block?
60 minus T equals
T
60.
minus 60 is equal to 6A. Do we understand this?
Sir.
T does not become equal to 12. It is 12 plus 60. It becomes 72 Newton. Do we understand this?
Yes, sir.
The difference between this question and the previous question. In the previous question, bacha, there was nothing on the reverse side. Tension was, this was the only force, bacha. There was no force on this reverse side. Do we understand this? That is why we use only this. But as soon as the blocks are hanging, bacha, the weight will come in the reverse direction, downward direction. Do we understand this?
Yes, sir.
With this, we come to an end of this chapter. Now, this section, we are done with the connected bodies. In the next class, we will move on to one more type of questions, and then we are done with this chapter. So, congratulations. We'll be done by Newton's law in the next class, and then we'll move on to friction. And probably by maybe, if everything goes well, maybe by Saturday, we will be done with Newton's laws and friction also. We move on to work, power, energy. Take care. Have a nice day. God bless you all. Please try questions on the sheet that I have sent you.
Sir.
Bye-bye.